will look like, and I will bring you a copy. We're going to look at the old test on Wednesday. So number 1, antiderivatives. And this is section 4.9. And this is exactly what Eddie was asking us today. Right? And Greg, those 2 functions, or 3 functions. Number 2, Riemann sum. And you have to know those 4 formulas. They're not formulas, they're identities, but whatever you want to remember them by. Then, number 3, the fundamental theorem of calculus part 1, which Eddie asked today, and part 2, which we've been using every day and today. To evaluate definite integrals. Of course, if you want to write it as a different topic, integrals, definite and indefinite, plus substitution rule, and we'll choose whatever you want. Number 5, total distance, plus displacement. Number 6, honestly, I can't think of anything else. Oh yes, properties. Of the definite integral.
Is this for next test?
Yes.
Okay.
Yes. That's everything from test for test 4 and everything for the final exam. I can't think of anything, so let's start with whatever you want.
The final is implemented.
Yes. Yes, that's why I need at least 2 sessions to review.
Can you
Yes.
break down the 4 identities for the Riemann sum?
The formulas.
Yeah.
Yes, or identities. Yes, yes, yes. The sum of 1 from I equals 1 through n is n. The sum of I from I equals 1 through n is n plus 1 over 2. I'm going to put as next because I want you to remember them together because it's easier. Is n plus 1 over 2, everything squared. And the last one, the sum of I squared, is this. In case you forget, I'll tell you where they are in your book. On page 374. For some reason, I don't see the sum of 1. I don't know. It's probably there. I just don't see it at this moment. So the sum of I, n plus 1 over 2, sum of I squared, n plus 1 to n plus 1 over 6, and the sum of I cubed, the same thing, but squared. So page 374. Is that okay? Okay, what would you like to start with from the topics? We have to cover all of them anyway. It doesn't matter which one you want to start.
Could you do one where we
Yes?
have to use one of the Riemann sums?
To find the area?
Yeah, one of those questions.
Yes. So let's choose a function. Anyone? Please choose a function. Remember, it has to be linear, quadratic, or cubic. We are restricted. We can If you say find the limit of the Riemann sum with sine x, I won't be able to. Okay, and give us an interval. So we need a function, either linear, quadratic, or cubic, and we need an interval.
This is for what type of?
Only linear, quadratic, or cubic.
Or I'm saying for the top and stuff.
Oh, this is the Riemann sum. The limit of the Riemann sum to find the area, the exact area. And now since we know integral, we know how to integrate, we know how to apply fundamental theorem of calculus, we will be able to check the answer. Do not forget the following. So I want to add them here before you choose the function, because I don't want to forget to refresh your memory on this. So the integral from a to b from f of x dx is indeed f of x, the antiderivative, evaluated. We've been doing this all day today. But remember, this function must be, yes, on the interval a comma b. Otherwise, you cannot determine it. You have to wait till calc 2. These are called improper integrals. When the function is not continuous, or when one of the limits is infinity, or both limits can be infinity. We can have from negative infinity to infinity, or we can have from 0 to infinity. Those are improper integrals. But not in this class, in the next one. Okay, so the other thing that I want to refresh your memory on is the integral from negative a to a from f of x dx has two possibilities, not always. So there is a possibility of none of the above. Zero, or twice the integral from 0 to a from f of x dx. When is it 0? When the function is, my markers are drying up. Thank you. Odd function. And when is it twice the integral from 0 to a? Yes, even function. If the function is not odd, if the function is not even, then you're going to have to determine it as is. But every time you have a symmetric interval, always check whether your function is odd or even. It will save you a lot of time. When you are given a definite integral, always check if the function is continuous before you proceed. Okay, so I'm waiting for your function and the interval. Now, if you want to be, you want to look at a difficult situation, you will not start at 0. And maybe we should look at 1. I will, honestly, I don't want you to spend 30 minutes on this, so I'm not going to use an interval that starts at 5 or 2 or 1. Because if you know what to do with 0 to 5, you're gonna know what to do with interval 1 and 4. But maybe we should work on one interval like that. It's up to you. Okay, I'll make one up if you don't want to give us a function and an interval. That's how my markers did. It's quite obvious. Okay, I'm going to choose f of x equals x squared minus 3, an easy one, from 1 to 4. It's not that easy, but this shouldn't be too difficult. Okay, ready? Okay. 3 preps. Why do I need 3 preps? Here's why. Because I need a lot of pieces to put or simplify before I do anything. Here it is. So first, I need this. Then I need this as step 2. And then I need this at step 3. if I don't determine these on the side, then putting them together will be more difficult. Okay, so we have to find delta x first. So let's find delta x. Can anyone give us delta x as the first prep? So yes, 4 minus 1 over n, excellent. 4 minus 1 over n or 3 over n, very good. Number 2. For number 2, I need the xi. If I don't determine xi and I don't simplify it fully, if I can or I can't, xi, but before I plug it in the function, okay, what is xi? Can I take your, just for 1 second, I want to show something. Okay. So remember what xi means. So let's take a look. We want to determine the area under this graph between the x-axis and the graph of the function. So I determine the first area using the leftmost point. Then I determine the next one using the height of the leftmost point, and so on and so forth. And I divide it into n subintervals. This one here is xi interval. This point is xi. So I have 1 in our case, plus 1, 2, 3, 4, 5, 6, 7 I delta x's. So this one is 0 plus 1 delta x. This one is 0 plus 2 delta x. This one is 0 plus 3 delta x. This one is 0 plus 4 delta x. So then what will xi equal to? In this case, we start at 1. Thank you. So it's 1 plus how many delta x's? I delta x, which is 1 plus 3i over n. Right? If x1 is 1 plus xi, is 1 plus delta x, x2 is 1 plus 2 delta x, then x3 will be 1 plus 3 delta x, dot, dot, dot. xi is 1 plus I delta x. Is that clear? Okay, now we have to plug this in the function. So this f of 1 plus 3i over n is, remember we chose f of x to be x squared minus 3. So can anyone tell us what to write first? 1 plus 3i over n, everything squared minus? That's it. When we square a binomial, we have to be very careful. When we square a binomial, how many terms do we get? Please don't say anything else but 3. Thank you. I was telling a couple of students who came in early. A friend of mine, at some point in time, not now, years ago, she applied for promotion and she didn't get it, so for whatever reason. So, and I said, what did you do when you heard the news? And she said, I didn't say anything. I went home and I screamed at a pillow. I said, why a pillow? She said, because I have neighbors. I don't want to disturb them. So yes, so when you say 2 or 4 terms, when you square a binomial, that's what I do. I go home and scream at a pillow because I have neighbors too. Okay, sorry about that. Okay, so I think I should tell you more jokes because I think it, yes, it wakes you up. Okay, I'll come up with all sorts of silly things. Okay, so please give me those 3 terms. My marker is drying up. Thank you. Thank you, Noah. Very good. Is this okay? First term squared plus 2 times the first times the second plus the second term squared. Please arrange it in descending order and please subtract -3 or 1 from -3 or -3 from 1, whatever you want to say. So this is our simplified function, 9i squared over n squared plus 6i over n minus 2. Maybe I should make my students pay for the markers if they don't answer quickly. I should collect 1 cent every time you do it. I have to wait. Every second, yes. Okay, finally, so we finally have the area, which is also the integral from 1 through 4 from x squared minus 3 dx. And why not calculate it before so we know what to expect? We're not cheating. We're allowed to. So this is x cubed over 3 minus 3x, everything from 1 to 4. I plug in 4 again. Okay. So 64 divided by 3 minus 12, but minus 1/3 and plus 3. 64 minus 1 is 63. 63 divided by 3 is 21. And this is minus 9, I think. And I get 20, no, I get 12. So I expect 12. So now, after I calculate and I know what to expect, I will go to the limit of the Riemann sum. And I have to get the same answer. So let's see. Limit as n approaches infinity from the sum from I equals 1 through n from delta x, which is 3 over n times this function, 9i squared over n squared plus 6i over n minus 2. We want to try and cut back a little bit on writing if we can. I'm going to take this constant outside in front of the summation notation, and I am going to write that the sum of the three terms is the sum of the first plus the sum of the second plus the sum of the third. So we can do two steps in one. Ready? So, limit n approaches infinity 3 over n. The sum from 9i squared over n squared plus the sum of 6i over n minus the sum of 2. Of course, from I equals 1 through n, from I equals 1 through n, from I equals 1 through n. In the next step, I'm going to move the constant outside, the 9 over n squared in front of the sum, 6 over n in front of the sum, and 2 in front of the sum, and I'm left with 1. Because these are the identities that I know. So limit n approaches infinity 3 over n. 9 over n squared, the sum of I squared. 6 over n, the sum of I, minus 2, the sum of 1. At this point, I will replace the summation notations with three identities. This one, n plus 1 to n plus 1 over 6. This one, n plus 1 over 2. And this one, n. Are you okay with that? Everyone? So, yes, of course, from I to n, I equals 1 through n. Okay, so limit n approaches infinity 3 over n. 9 over n squared, n plus 1, 2n plus 1 divided by 6, plus 6 over n, n plus 1 divided by 2, minus 2n. Okay, so we eliminated all the summation notations. We replaced them with the identities. And now I'm looking for the least common denominator. I would simplify by 3, but I would not simplify by 2. Because if I simplify by 3, I get 2n in the denominator, so I have the same denominator. Why not? I should not simplify the second one. I'll simplify by 1n, one from the top and one from the denominator, and by 3. But I will leave the least common denominator to be 2n, so I will not simplify here. In some of your tests, you apply L'Hopital's rule, but not write the limit. So please, you can do that. So if you don't have a limit, you cannot apply L'Hopital's rule. So please look, I wrote the limit, please, on your test. So please keep that in mind. So I have 3 over n, and then I'll multiply these two, and I get 2n squared plus 3n plus 1, but I multiply by 3. So 6n squared plus 9n plus 3. Everything is over 2n. And here, plus 6n squared plus 6n. And this one gets a 2n, minus 4n squared. And if I don't get 12, it's your fault. I'm kidding. I'm hoping to get to 12. I don't know. We'll see. Okay, now I collect my terms. I have 12 minus a 4, which is an 8. Looks promising. So this is limit as n approaches infinity. 3 over 2n squared. I multiply these two now. 6 plus 6, 12 minus 4 is 8. And this is plus 15n, and plus 3. I already have the answer from pre-calc. But you can say, no, I want to see it, use L'Hopital's rule. I will use L'Hopital's rule. So the numerator approaches infinity, the denominator approaches infinity. I will take the 3 or 3/2 in front. They are factors. I don't care for them. I don't want them in there. So 3 over 2, limit n approaches infinity. I differentiate the top to get 16n plus 15. I differentiate the denominator to get 2n. I differentiate again, I get 16 over 2, which is 8. And 3 over 2 times 8 is my 12. I would do that, to tell you the truth. I would, on the test, I would check find the area with the definite integral first to see what to expect. And then, yes, please don't.
Where did 8n to the second come from?
I have 6 plus 6 minus 4. 12 minus 4.
I thought they canceled out.
No. I have a 6 plus 6. I'm not going to fudge it, I promise. So, so 6 plus 6 is 12. 12 minus 4 is 8. And then I have the 15 and I have the 3. I took 3/2 outside. I differentiate the top to get 16 plus 15. And I differentiate the denominator to get 2n. When I differentiate again, I get 16 over 2, which is 8 times 3/2.